Hey everyone, welcome back, and today let's solve Leetcode problem 20 titled Valid Parentheses. So just a quick FYI before we get too deep into this video, my microphone's having a little bit of issues. I might sound like I'm very far away from the microphone in certain parts of the video when I'm actually typing out the coding solution. The reason why is my stand broke temporarily. And so yeah, we're just going to have to make do with the current microphone status, right? So let's go ahead and get into the problem statement here. It says that we're given a string S containing just the characters of opening and closing parentheses, opening and closing curly brackets, and opening and closing straight brackets. And we have to determine if the input string is valid. Now, an input string is valid if open brackets are closed by the same type of brackets, that open brackets have to be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type, meaning we can't close a parenthesis with a curly bracket. They're not of the same type. It wouldn't be valid, if you will. So in example 1, we have our input string has to be just an opening parenthesis followed by a closing parenthesis. That's completely valid because it follows all three of these conditions, right? The opening parenthesis is indeed closed by the same type of closing parenthesis. They're closed in the correct order, where the opening parenthesis comes first, and the closing parenthesis being mapped to this opening parenthesis is of the same type. They're both parentheses. In example 2, we have our input string S to be, again, pair of opening and closing, pair of opening and closing, and pair of opening and closing, each pair of a different type. But that's completely fine because the actual things that close each other and open each other, that are next to each other, they are still of the same type, and so that the pairs match out. And finally, in example 3, or rather in the example 3, we have our opening parenthesis being closed by a different type of bracket. That wouldn't work. They're not of the same type. Although they are in the correct order, they're not in the same type, and so this is false. And finally, example 4 is still true. Why? Well, because within these two parentheses, we still have this pair or these two straight of the same type brackets being mapped with each other, and so these parentheses, although they're outside and not adjacent to each other, are still indeed equal, right? And so we still have an output of true, where the opening parenthesis is still being closed by the closed parenthesis, and we can kind of just ignore or pop off or don't worry about these two middle ones. So for the constraints here, we see that the length of our input string S is going to be between 1 and 10 to the 4th power, and our input string S is only going to contain parentheses only in the string, and so it's always going to for instance, be valid or follow what the problem statement told us. We don't have to worry about any weird edge cases where we have invalid inputs or inputs that don't have just brackets or parentheses and have some other type of characters, right? So with that, let's go ahead and get into how we actually solve this problem and a main observation to make. And a main observation to make is actually note the relationship between how open brackets and closed brackets are being closed and how we actually check if they're valid when determining if the entire string is valid. And we saw a good example of this in example 4. If we iterate through the input string S regularly, we'll first encounter this opening guy, right? As long as we start with an opening, we're fine, because of course we can't start off with a closing bracket or parentheses. That wouldn't make sense because we always want opening to come first. We see this next opening, but since it is an opening, we don't immediately return false because this isn't valid, because it could be closed by another type of the same type before we close this opening. And so as long as we see this, immediately after we see the same type closing, we know we can pop off this open and basically consider that to be a valid pair. We don't have to worry about that. And then look at this next closing that's closed by then this remaining opening parenthesis. Now that has the same property of a stack. Again, it requires whether each opening bracket, or rather it requires checking whether each opening bracket in the string is actually properly closed in the correct order. That's a very natural last in, first out, or LIFO structure, which is the exact property of a stack. Again, as we scan the string from left to right, like kind of glossed over in example 4, we'll push each opening bracket onto the stack. And when we encounter a closing bracket, we have to then check, okay, whether it matches the most recent opening bracket that matches with it on top of the stack. And if it does, we can pop it off. It's basically a valid pair that we don't have to worry about. But if it doesn't, we know that the string is immediately invalid because we're trying to close an opening parenthesis with a different type. That's immediately invalid. And this nesting and reversal of the order, we can't actually accurately manage that using any counters or queues because they don't have that LIFO property and they don't preserve the necessary order of matching, right? And so this stack is going to perfectly handle their problem requirement. It's going to allow us to access the last unclosed bracket for validation to make sure it's the same type and in the correct order, and that's why it's going to be how we solve this problem as well, using its last in, first out, or LIFO structure, right? So let's go ahead and start coding the solution, and my mic might be a little little bit farther away from my mouth, as I have to actually reach for the keyboard now. But effectively, the way we're going to start this is actually initialize the stack, of course. So oh, sorry, looks like I wasn't even typing. I'm just going to call it stack. Doesn't really matter what you call it, and we're going to be using this to actually manage all the different pairs of opening and closing parentheses that are mapped to each other as we iterate over them, as we iterate over the input string s. And let's actually initialize our hash map. The whole point of this hash map is to map every single opening bracket, or rather closing bracket, to its opening pair, so we know whenever we encounter a bracket, we know we can check if it's closing or opening, and if it's closing, if it closes the correct type, right? Meaning if it's mapped to the same corresponding bracket or type, right? So we know a closing parenthesis is always going to be mapped to an opening parenthesis, because of course they are of the same type. Very similarly, we know that a closing, closing curly bracket, that's going to be mapped to an opening curly bracket. And finally, we know that a closing straight bracket has to also hence be mapped to the same type of, closing, or rather opening bracket. And we're always putting the closing brackets first, because when we're checking, or rather iterating through the input string s, we always check if the current bracket is closed, because if it's closed, we have to have an open one before it. We can never start a pair with a closed one, because a closed always has to come second after its corresponding same type opening, right? If we have an open, that's fine. That doesn't immediately make it invalid, right? We can just push it onto the stack. But whenever we see a closed one, it has to always be in the correct order, meaning after an open one in the same type as well, which is what we check for whenever we encounter a closing bracket in the input string s. So with that said, let's go ahead and actually begin iterating over the input string s. We don't really care about indices in this case, and so we can just go for a very standard while loop of for I in s, where I is basically our iterator, or each element, or parenthesis or bracket in the input string s. So for every I or element in the input string s, let's first check if the current element I, or if the current character I, if it's actually a closing bracket or not. And a very simple way to do this, especially in Python here, is basically to just check if I is in H. Because checking this, we're basically saying if I is in H, it's one of these initial key pairs, meaning it's one of these initial closing brackets or closing parentheses. That's why we put the closing parentheses or slash brackets first, because it allows us to check if any elements are in the hash map, or if they are actually closing brackets in a much easier fashion, right? Now, if it is a closing bracket, then we need to make sure that the topmost element of the stack is an opening bracket of the same type as this one, to make sure that this is actually a valid pair, and we're not closing any previously opening brackets with incorrect types. So, if stack at -1, basically meaning the most recent element, rather the most recent opening bracket that we've encountered so far, or rather the last opening bracket that we've seen so far, as long as that's equal to h at I, and h at I, keep in mind, is the opening counterpart, or the opening same type bracket of the current closed one. But we also have to make sure that stack is non-valid, because we can't check for stack at -1 if stack is empty. So if stack is non-null, meaning if stack and this most recent or stack at -1 opening bracket that we've seen before is the same type of thing as the current closing one, we know that this is valid, and so we can just pop off the stack, indicating that it's just one more pair that we don't have to worry about. We can pop it off from the stack, because at the end of the day, stack is only going to contain non-valid pairs of brackets that are in the correct order, or that are just not the same type, and that's what we're going to be checking for at the end of this iteration. Now, if this is the case for if I was in H, meaning if I was a closing bracket. What if stack at -1 was not equal to H at I? Meaning, what if the most recent opening parenthesis or opening bracket that we've seen wasn't of the same type as the current closing one? Well, then if that's the case, we immediately have to return false, because it breaks the problem's rules of having to close opening things with their same closing counterparts of the same exact type, and so we immediately have a return false statement if we see the most recent opening bracket is not of the same type as the current closing bracket. Now, what if I is not even in H? What if we don't even enter this conditional? In that case, that just means that the current element I, or the current character I, is an opening bracket. If it's an opening bracket, we can't immediately invalidate it, because opening brackets are kind of independent, if you will. And so if that's the case, we can really just, in the else conditional here, we can really just add to our stack this opening bracket. And this is going to be our new most recent opening bracket that we've seen so far across the input array or rather the input string s. And effectively, once this for loop iterates, we want to return if our stack is non-null. Because if our stack is non-null, that means we popped off all kind of valid pairs of brackets slash parentheses. We didn't have any pairs that didn't have that property. We did not pop off anything, and so we have to return if stack is non-null, meaning if stack is not, or just not stack, meaning we don't have any elements in the stack, right? Right, so unless I made any syntax errors here, this should be accepted, there should be a valid solution, so let's go ahead and verify that. And as you can see, this really is just about as efficient as you can get it to be. So I don't know if my microphone turned off here, but just to kind of reiterate what I was saying here, we just return not stack because that's going to return if the stack is null or not, meaning if it has any elements or not. If the stack does not have any elements, that means we've popped off all of the pairs of valid parentheses slash brackets in the input string s. None of them were non-valid, none of them were in the wrong order or different types, and so we're good, right? But if we didn't pop off any elements or pairs of parentheses in the stack, that means not all of them were in the correct order / not all of them were of the same type, and so we had some extra non-valid elements that we didn't actually pop off from the stack. Hence, meaning that if not stack was false, that would mean that the stack still had invalid elements, meaning that our input string s would be invalid, and so we'd return false in that case. And as you can see, this really is just about as efficient as you can get it to be. So for memory and space complexity here, for runtime complexity here, it's really just going to be linear. Why? Because this really is just a singular pass solution in the input string s. We're going through each character or element exactly once. And for the runtime or memory or space complexity, it's also going to be linear because of the stack, as at worst case it could hold all elements in the input string s. If all of them are invalid, we didn't get any pair of elements that were actually valid across the entire input. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.